Today we're going to be looking at some applications of the Pythagorean theorem. We're going to be looking at how we can use them with shapes and to find missing parts of shapes. Our first one right here says go and find x, and they have us a trapezoid. Looking at our trapezoid, I want to go and think about this thing as basically a rectangle and a triangle. Looking at this, if this side is 5, that means this side is 5 also. So I can find this missing side over here by doing 11 minus 5. So that tells me this piece right here is 6. This one transfers over here to 8. I can now go find my x by using my Pythagorean theorem. The a squared plus b squared is equal to c squared. The 8 and 6 are my a and b, so 8 squared plus 6 squared is equal to my c squared. So this is going to be 64 plus 36. 64 and 36, I add those together and get 100. I take the square root of both sides because I'm looking for this missing side, not the side squared, and the square root of 100. C is equal to 10. But remember, C is really my x, so therefore the final solution is x is equal to 10. Here we're looking at another example here. This one is a square. And our square, they have given us the diagonal of the square, and they're asking us to find the side of the square. That's where our x is located. Well, if that's x, that means each of these are also x. So remember, we're still going to be using our Pythagorean theorem. A squared plus b squared is equal to c squared. This one right here is going to be my c. This is my a and my b. My a and my b, they're the same thing. So I'm going to take and have x squared plus x squared is equal to 5 square root of 2 squared. Well, x squared plus x squared gives me 2x squared. I have to multiply this one out, so I'm going to be doing 5 square root of 2 times 5 square root of 2. So 5 times 5 is 25. This is now square root of 4 because I multiply this stuff inside the radical. So this becomes 25 times 2, and 25 times 2 is 50. So I put 50 right here. I have to divide both sides by 2 because I need to isolate the x. So I have x squared is equal to 25. I take the square root of x squared, the square root of 25. X is equal to 5. The sides of my square is 5. Okay, now our last example that we're going to be looking at says find the length of a rectangle with a diagonal of 8 and a width of 4. Well, this time they didn't give us a picture. So I'm going to go through and draw us a nice pretty little rectangle. There's my rectangle. I'm going to go put me a diagonal in here. My diagonal goes across like this. Now let's go and label what they gave me. They told me my diagonal is 8, so that means this one is 8. The width is the square root of 4, and I am looking for the length. Well, the square root of 4 is the same thing as saying 2, so I can just rewrite that as 2. I'm going to go over here and use my Pythagorean theorem. A squared plus b squared is equal to c squared. So I'm going to have 2 squared plus L squared is equal to 8 squared. 2 times 2 is 4, so I have 4 plus my L squared is equal to 64. I'm going to take and subtract 4 from both sides. L squared is equal to 60. Take the square root of L squared and the square root of 60. L is equal to, well, square root of 60. I got to go and simplify that. So that's going to be 4 times 15. I choose 4 and 15 because 4 is a perfect square. This is a perfect square, so therefore it will be able to come out as a 2. So my final answer is going to be 2 square root of 15. This one comes out to 2 square root of 15 when we pull the 4 out.
You wouldn't have to simplify 5 to 15.
This will be our final answer. That is the length of our rectangle. Can't do anything with the square root of 15 because 3 times 5 is 15. There are no perfect square factors of it. Pythagorean Theorem. Take your time. Pay attention to what you're doing. And as always, good luck.